So in this video, we're just going to do kind of an intro to surveying. And this will just go over some of the skills that you're going to need to have in order to be successful doing the other topics in surveying. So the first thing that you're going to have to be able to do is convert angles. So a lot of times we're used to having angles written in decimal form. So for example, 37.4964 degrees. That's how you would see it. But we need to be able to put that into the form of degrees, minutes, and seconds, because that's the form that surveyors often use. So in order to do that, you really just need to know a couple of conversions. So you just need to know that there are 60 minutes in 1 degree and that there are 60 seconds in 1 minute. And once you know that, then you can just do basic conversion to get your decimal into this form. So first things first, we know that we have 37 degrees, and then we also have 0.4964 degrees, which can be converted. So if you remember, 1 degree is equal to 60 minutes. So your degrees will cancel. You'll be left with minutes. So you can plug that in your calculator. 0.4964 times 60 is equal to 29.784 minutes. So now we know that we have 37 degrees and 29 minutes plus 0.784 minutes, which can be converted to seconds because we know that there are 60 seconds in 1 minute. So your minutes will cancel. You'll be left with seconds. Plug that into your calculator, and you get 47 seconds. So now you have a full answer of 37 degrees, 29 minutes, and 47 seconds. So we know that 37.4964 degrees is equal to 37 degrees, 29 minutes, and 47 seconds. And your conversion is as simple as that. If you can just remember these, then you can go back and forth. Now, if we wanted to go back the other way and say we want to get 37 degrees, 29 minutes, 47 seconds into decimal degrees, you're going to do a similar approach. So again, we've got to get, this is already in degrees, but we need to get this and this into degrees as well. So we're going to go 29 minutes, and we want that in degrees, so we put degrees on top, and we need minutes to cancel, and we know that there are 60 minutes in 1 degree. So that's going to be equal to 0.4833 degrees. And then we need to convert our seconds into degrees. So we've got 47 seconds. And we know that there are 60 seconds in 1 minute. So then our seconds will cancel. We'll be left with minutes, but we need to get to degrees. So we know that there are 60 minutes in 1 degree. Our minutes will then cancel with each other. And we'll be left with 0.0131 degrees. So now we have everything in degrees and we can just add all of those things together. So we've got 37 degrees plus 0.4833 degrees plus 0.0131 degrees. And when you add all of those up, you get 37.4964 degrees, which is good because that's what we started out with in the first problem anyway. So again, it's just simple unit conversions to go back and forth. So that's one thing that you'll need to learn how to do and be efficient at in order to be successful in surveying. Another thing is to remember your trig properties. And the first thing you need to remember how to do is the law of sines and the law of cosines. And these will help you in finding angles and distances. A lot of surveying is just triangles in geometry and learning how to manipulate it in order to find certain angles and certain lengths and distances. So if we set this up as it should be lowercase a, b, c, and then a, b, c. So notice the way that I've set this up, that the letters are opposite of each other that correspond. So the angle of C is opposite of the distance of C, and the angle B is opposite that side B. So the law of sines says that the sine of A over the distance A is equal to the sine of B over B, or any combination thereof. So the sine of some angle over its corresponding distance over the sine of a different angle on that triangle over its corresponding distance. So this over here could be sine C over C as well. Or it could be reversed so that these are equal as well. So again, any version of that, and that's the law of sines. So the best way to write that is just going to have these all be equal to each other. So again, you can come in and interchange these or remove them. So you're left with that, or you're left with that, or you're left with that. Any version, and you're going to get the right answer. So for example, if we had some triangle and we want to find this angle here, and we know this is 20 feet and this is 15 feet. Then we can use the law of sines to figure out theta. If we know that this, let's just say this is 12 degrees. So we're going to have the sine of theta all over that length that's opposite from that angle. So 20 feet is equal to the sine of our known angle, which is 12 degrees, all over the length that's opposite of that, which is going to be 15 feet. And then you just cross multiply. So you'll end up with 20 sine 12 is equal to 15 sine theta. So then you can get theta equals the sine inverse of 20 sine 12 all over 15. Plug that into your calculator. And you'll get that theta equals 16.1 degrees. Now for the law of cosines, you're going to use the same triangle as a reference, except that the law of cosine says that c squared equals a squared plus b squared minus 2ab cosine capital C, where this over here was little c. So again, you can interchange this and write it multiple different ways. So you can have a squared equals b squared plus c squared minus 2bc cosine of a, or b squared equals a squared plus c squared minus 2ac cosine of b. The biggest thing you need to remember when writing these equations is that these always correspond with each other. So you've got b and b, and then also these two correspond with these two. Those are the same values there. And then you should be able to write your equation correctly. So if we run through an example of the law of cosines really fast, let's just say we've got some triangle, and we'll just say this is 100 feet, 75 feet, and 30 feet, and we want to find this angle theta there. So we're looking for theta over here, which we've identified as b up here. So we want to use this equation because it's got the angle b within that equation. So we're going to use b squared equals a squared plus c squared minus 2ac cosine of b. So we can go ahead and label these so it corresponds to this same triangle up here to make our lives a little bit easier. So this is b, which makes this b here. And then we had a over here and c up here. So this is c down here because it's opposite again. And so opposite of here, that's going to be a there. So now that we've got that labeled, we just plug everything into this equation. So b squared, so that's going to be 75 feet squared equals a squared, which is 30 feet squared, plus c squared, which is 100 feet squared, minus 2 times a, which was 30 feet, times c, which was 100 feet, times the cosine of b, which is what we're looking for. B is our theta. So you can go ahead and exchange that and say theta right there. And then you just solve for theta. So theta is going to equal the cosine inverse of 75 feet squared minus 30 feet squared minus 100 feet squared all over a negative 2 times 30 feet times 100 feet. And then you can just plug that all into your calculator. 75 squared minus 30 squared minus 100 squared, negative 2 times 30 times 100. And you're going to take the cosine inverse of that. And you'll get 28.5 degrees. Now it's really important when you're doing this that your calculator is in degree mode and not radian mode. Otherwise you will get the really wrong answer. All right, so that's just a quick review on the law of sines, law of cosines, and that's going to help you out in your surveying class as well. Another thing that you want to review is just your basic trig properties. So if we all remember our SOHCAHTOA that we learned, all this means is that the sine equals the opposite side all over the hypotenuse. So again, that SOHCAHTOA comes from just the first letters. So we've got our SOH for our SO. And then for our CA, we've got the cosine equals adjacent side over the hypotenuse. And then our TOA is going to be our tangent is going to equal our opposite over adjacent. So again, if you're looking at a right triangle, then you're going to have some angle theta here. So the sine of that theta is going to be your opposite side, right? Because it's opposite of that angle over the adjacent side of that angle. So the side that is right next to your angle, that is not your hypotenuse. And so your hypotenuse is this one over here, which connects the two sides that make up the right triangle. So your adjacent and your opposite make up this right triangle. So opposite of that 90 degrees is going to be your hypotenuse. And it's as simple as that. You just plug it into your calculator after that. So if we had, for example, this right triangle here, and we're looking for that theta, and we know that this is 10 feet, and this is, say, 15 feet, then we know, so in this case, we know our opposite side and our hypotenuse. So if we look at SOHCAHTOA, we know that our sine is the one that uses our hypotenuse and our opposite side. So sine equals opposite over hypotenuse, which is going to equal 10 feet over 15 feet. So sine theta equals 10 over 15 because your units will cancel. And so in order to separate your theta from this sine function, you do the opposite of your sine function. So you're going to do the sine inverse of this entire thing. And so these are going to cancel, so you'll be left with just theta on that side and then the sine inverse of 10 over 15 on this side. So then you just plug that into your calculator. and you're left with 41.8 degrees. And it's really that basic. So another thing that you'll be looking a lot at in surveying are these measuring instruments. And they measure distances and angles. So let's just say we've got this measuring instrument on some sort of slope. And at the end of it, there is a tower of some kind. And you want to know the height of this tower. But all you know from your measuring device is, so if this is 90 degrees right there, you know this angle coming down and this angle coming up. So we'll say this angle coming up is going to be 10 degrees, and this one will be 15 degrees coming down. But you've also measured this distance here to the base as being 500 feet away. So when you're looking at this picture, you can identify a couple different triangles within this picture. So the first one I see is this triangle here, and then the second one I see is this triangle here. So we'll go ahead and look at that first triangle. So again, we got a right angle there. We know that this is 500 feet. And we know that this is 15 degrees. Now again, remember that we're trying to find this H here. And so that H is made up of this distance on the second triangle and this distance on the first triangle. So H is going to be equal to, let's just name this Y for the first triangle and Y for the second triangle. So that's going to be, H is going to equal Y1 plus Y2. So from our first triangle, we know that this is Y1, and we need to find Y1. So looking at this triangle, we know which sides of the triangle. We know the hypotenuse, but we also know the angle opposite of Y1. So we have information about the hypotenuse and the opposite. So we're going to use the sine of theta again is equal to the opposite over hypotenuse. And in this case, we know theta is 15 degrees. And we don't know our opposite, that's just Y1, but we know our hypotenuse is 500 feet. So you can now just solve for Y1 in this equation. So Y1 is going to equal 500 feet times sine of 15 degrees. So we get that Y1 is going to equal 129.41 feet. So now we've got Y1, and we can go ahead and look at this second triangle. And in this second triangle, we only know this angle here. So we can't really do a whole lot with that, but we also know that this side of this triangle is equal to this side of this triangle. So we're going to go ahead and use triangle 1 to solve for this side right here so we can use it on our second triangle. So we can use Pythagorean theorem. I think that's how it's spelled, Pythagorean theorem, which says a squared plus b squared equals c squared. So the way we have it written, these are just the different sides of your triangle. So we can rewrite this as x squared plus y1 squared equals hypotenuse squared. But again, we know our y1 now because we just solved for it, and we know that our hypotenuse equals 500 feet. So x squared plus 129.41 feet squared equals our hypotenuse squared, which is 500 feet squared. So you can go ahead and solve for your x, which is going to be the square root of 500 feet squared minus 129.41 feet squared. And you just plug that into your calculator. And you will get that x equals 482.96 feet. And again, we solved for this length here, but that is equal to this length here. So now we know that the length of that is going to be 482.96 feet. And so for our second triangle, again, we're trying to find this total height, which is equal to y1 plus y2. We found y1 from the first triangle. Now we need to find y2 from the second triangle. So in this case, we know this angle, and in relation to that angle, we have information about our adjacent side and our opposite side. So we know that the TOA part of SOHCAHTOA uses the opposite and adjacent. So we're going to go ahead and do the tangent of theta equals opposite over adjacent. So we know theta is 10 degrees. Our opposite we don't know, so we're just going to plug y2 in there. And then our adjacent is what we just solved for, is 482.96 feet. And so you just bring that over to this side and you can solve for y2. It's going to equal 482.96 feet times the tangent of 10 degrees. And we're going to get that y2 equals 85.2 feet. So now we've got our y1 and our y2, and we know that our tower was made up of y1 and y2, which equals the total height. So our total height is going to equal y1 plus y2, which is equal to 129.41 feet plus 85.2 feet. Plug that into your calculator, and you're going to get that the total height of our tower is 214.6 feet. So a lot of surveying, again, is just going to be recognizing your different geometric shapes, breaking them down, and then solving for your unknown pieces. Now, as I went through this, if you had any questions about the algebra and how I was getting from step to step, go back and review some of those algebraic principles. either on our website or in a textbook that you have, because we've got information about that as well. Or you can head over to our homework help page, and we'll be able to get you more tailored help there. Or head over to our tutoring page and schedule an appointment, and we'll be able to sit down and discuss some of these principles.